Section 7.2 is on multiplying polynomial expressions and functions. In the expression b to the n, b is called the base and n is called the exponent. Exponential form can be represented in repeated multiplication form, an exponential form, or as a simplified numeric value. For the first example, negative 3 to the fourth, the exponent is just on the 3, so the repeated multiplication form has 3 being multiplied by itself 4 times, with a single negative, giving us a result of negative 81. In the second example, both the negative and the 3 are part of the base, so we've got negative 3 times negative 3 times negative 3 times negative 3, a total of 4 negatives making this result a positive 81. So it's important in exponential form to note whether or not I have a negative inside or outside of a parenthesis. A single negative, it's not being repeated, it's not part of the base in the first example, whereas both the negative and the 3 are part of the base in the second example. We can see that again in the next two examples. The 2 is not part of the repeated multiplication, it's just x as the base. So this is a 2 multiplied by 5 x's, 2x to the fifth. Or if there are parentheses, 2 and x are both part of the base, so I have 2x times 2x times 2x 5 times. And in this case, to multiply all the 2's together, I could simplify this as 32x to the fifth. Alright, so let's check out an example here. If I have 5 squared times 5 to the 6, what's really going on there? 5 squared is 5 times 5 times 5 to the 6 has 6 copies of 5. 1, 2, 3, 4, 5, 6. Alright, and so if you have 2 copies of 5 and 6 copies of 5, what you've got is a total of 8 copies of 5. That brings us to our first property, the product property for exponents. If you're multiplying 2 bases together, you're going to be able to add their exponents. 2 copies of 5 and 6 copies of 5 result in 8 copies of 5. M copies of B and N copies in B result in M plus N copies of your base B. So let's look at example 1. We're going to use this property. 3x times 7x to the fourth. Multiply your numbers as usual. 3 times 7 is 21. Here there's 1x and here there are 4 x's, so I'm going to have a total of 5 x's, x to the fifth. 4 times negative 6 in the next example gives us negative 24. X to the fifth times x to the third will be x to the eighth, adding up the exponents there. Another multiplication, 4 times negative 2 is negative 8, and then we look at our x's and our y's. 3 and 2 make x to the fifth, and y to the fifth, and one more y will give us y to the sixth. Part D, x squared times x to the sixth times x to the third. 2 plus 6 is 8, plus 3 is 11, so I'm going to have x to the 11th here. Let's go to the next page. In example 2, we want to quickly make a cautionary note about the difference between when I add and when I multiply. When I add two terms that are like, such as 9x plus 9x, I arrive at 18x. When I multiply two monomials, such as 9x times 9x, I arrive at 81x squared. When you're adding like terms, you do not change the variable component. When you're multiplying terms, the variable component will change. You're saying, I've got an x times an x squared is a simplified form of that. Okay? If you're adding, you cannot simplify if the powers are not identical. You cannot add them if they're not like terms. If you're multiplying, you can multiply them by adding the powers. So 2x to the fourth times 8x to the third will be 16x to the seventh. If we're subtracting and they're like terms, we can go ahead and subtract them. We'll get 3 minus 8 is negative 5x squared. The exponent does not change when you're adding or subtracting as long as the terms are like. You can do that. When I multiply them, the exponent does change. 3 times negative 8 is negative 24. And x squared times x squared is x to the fourth. Now, you cannot combine 7x squared and negative 7y squared because the variables are not the same, so we cannot simplify this expression. We could write it out with parentheses. We could write it as 7x squared minus 7y squared, but there's something we could do to combine these into a single term. I can multiply two different variables, however. Negative 7 times 7 will be negative 49, and when I multiply x squared times y squared, I get x squared times y squared, so I can combine those to a single term. So remember, in order to add or subtract, they must be like terms. Same variables, the same power. But this is not necessary when multiplying. In example 3, we're going to find the product of a monomial and a polynomial, so we're going to be using the distributive property. 5x times 4x is 20x squared. 1 and 1 make 2 x's there. Plus 5x times 7 is 35x. Alright, let's look at part B. Distribute again. 3 times 4 is 12. And t squared times t to the third will be t to the fifth. 2 plus 3 is 5. Minus 3 times 7 is 21. T squared times t will be t to the third. 2 plus 1 is 3. Multiply your numbers, multiply your variables. When multiplying the variables, remember to add the exponents. Alright, I've got 6 times 3 is 18. X to the third times x squared is x to the fifth. 6 times negative 2 is negative 12. X to the third times x is x to the fourth. And 6 times negative 7 is negative 42. And we'll keep our x to the third there. In part D, we're going to distribute. Negative 2 times 3 is negative 6. 1x times x squared is x to the third. And I'm going to have y squared. Negative 2 times negative 5 is going to be negative 10. X and x for x squared, y squared and y for y cubed. And last, negative 2 times 1 will be negative 2x, and y squared times y squared will be y to the fourth. Let's look at the next page. Multiplying two binomials is really just a matter of using the distributive law twice. So when I use the distributive law the first time, I'm going to take x times the entire second parenthesis. So x times x plus 5. When I use the distributive time the second time, I'm going to take 3 times the second parenthesis. So plus 3 times x plus 5. So the net result of using the distributive property is that I have x times x is x squared, plus x times 5, or 5x, and 3 times x is 3x, and 3 times 5 is 15. Combine this all together, and we have our x squared plus 5 plus 3 is 8x plus 15. So instead of having to write the first line out here, what most people do is remember that since x is going to be multiplied by the entire second parenthesis, we'll just go ahead and multiply it by both parts in it. Same thing for the 3. Let's go ahead and multiply both parts in the parenthesis. So let's find our product here. X times x is x squared. X times 6 is 6x. We're finished with x now. We've multiplied x by both parts of the second parenthesis. We start with 4. 4 times x is 4x. And 4 times 6 is 24. If necessary, combine like terms. I do have some like terms in the middle there. So we have x squared plus 10x plus 24. Let's distribute in the next one. 2x times 3x is 6x squared. Keep going with the 2. 2x times 7y is plus 14xy. Now we're finished with the 2. We've distributed to both terms. We're going to start with a negative 5y. Negative 5y times 3x is negative 15xy. And negative 5y times 7y is negative 35y squared. Combine your like terms. We're going to have 6x squared. 14 minus 15 will give us negative 1xy, or just negative xy. Then our minus 35y squared. Let's look at part C. 4x times 4x is 16x squared. 4x times 7 will be plus 28x. Negative 7 times 4x will be negative 28x. And negative 7 times positive 7 will be negative 49. When I combine these, the middle two terms are opposites, so they're going to add to 0, and I'm going to get 16x squared minus 49. Got a few more to look at. Let's look at part D. 4w squared times 3w will be 12w cubed. W squared times w will give us 3w. 4w squared minus times negative 5. 4w squared times negative 5 will give us 20w squared, negative there, 20w squared. And then the 2 times 3w will give us plus 6w, and the 2 times the negative 5, a minus 10. There are no like terms here, so nothing to combine. That one is already finished. Let's look at part E. There are two different distributes to do here. So I'm going to do the first one first. 2 times 3x is 6x minus 2 times 2y is 4y. So we did our monomial distribute. Now we're going to go ahead and do the binomial distribute. Take 6x times 5x and times 4y. They'll give us 30x squared minus 24xy. And then we'll take the negative 4 times 5x and the negative 4 times negative 4y. Will give us negative 20xy, and two negatives there will give us positive 16y squared. Combine our like terms, we'll get 30x squared minus 44xy plus our 16y squared. Let's look at part F. There's two distributes to do here as well. Now I can either do my monomial distribute first or my binomial distribute first. Let's go ahead and do the binomial distribute first. And we'll have 3x times x squared times 2x is 2x cubed. X squared times 5 is 5x squared. Negative 2 times 2x is negative 4x. And negative 2 times 5 is negative 10. Now we're ready to do the distribute with the monomial. So we're going to multiply that monomial 3x times every term on the inside. So 3x times 2x cubed is 6x to the 4th. 3x times 5x squared will be 15x to the 3rd. 3x times 4x will be negative 12x squared. And 3x times the negative 10 will give us a negative 30x. Okay. So it doesn't matter if I multiply the first two together first, the monomial times the binomial, or if I do the binomial first, then use the monomial. I can do it in either order I choose. Go on to the next page. Multiplying larger polynomials. Okay, so if I want to multiply a binomial and a trinomial, I just need to apply the distributive property 3 times to get it through every single term in the trinomial. So 2x times x squared is 2x cubed, plus 2x times 5x is 10x squared, and then 2x times negative 6 will be negative 12x. Now let's work on the negative 4. Negative 4 times x will be negative 4 times x squared will be negative 4x squared. Negative 4 times 5x will be negative 20x, and negative 4 times negative 6 will give us a positive 24. So when we simplify, we get 2x to the 3rd plus 6x squared, 10 minus 4. Negative 12 and negative 20 will give us minus 32x plus our 24. In part B, we're going to take x squared times all 3 pieces in the second parenthesis. We're going to get 3x to the 4th minus 5x to the 3rd minus 2x squared. Now we're going to take the negative 2x times all 3 terms minus 6x cubed. 2 negatives make that positive 10x squared, and 2 negatives will make that plus 4x. And last, the 4 times all 3 terms. 4 times 3x squared will be plus 12x squared minus 20x and a minus 8. Combine your like terms. We'll have 3x to the 4th. Negative 5 and negative 6 will add to negative 11x cubed. Negative 2 and positive 10 will add to positive 8. Plus 12 will add to positive 20 x squared. Positive 4 and negative 20 will add to negative 16x. And our constant is minus 8. Alright, in example 7, we have two functions, f and g. I want to find the following by hand. part A we want to multiply f times g. Then we're going to use our result from part A and plug 2 in. So we have 2x minus 3 times 3x squared plus 4x minus 7. We're going to use the distributive property. So we're going to get 6x cubed plus 8x squared minus 14x. Then we'll start with the negative 3, so it'll give us negative 9x squared minus 12x and a positive 21. Let's combine like terms. We get 6x cubed plus 1x squared minus 26x plus 21. Now in part B, they want us to plug negative 2 in place of x in the function f times g. So we have 6 times negative 2 cubed plus negative 2 squared minus 26 times negative 2 plus 21. Negative 2 cubed is 8, so this is 6 times negative 8. Negative 2 squared is 4, so plus 4. Negative 26 times negative 2 is positive 52 plus 21. 6 times negative 8 is negative 48 plus, these are all positives, let's add them up, 77. And finally, negative 48 plus 77 is 29. Let's go on to the next page. The average annual cost of tuition at a community college in dollars per student can be modeled by the equation C of t equals 55t plus 832, where t is the number of years since 1990, and the enrollment at all community colleges in millions of students is E of t equals 0.15t plus 3.84. Again, t is the number of years since 1990. Let's find an equation for the product function, c times e. So 55t plus 832, that's c, times e, 0.15t, plus 3.84. Let's multiply these together to find c times e. 55 times 0.15 gives us 8.25 t squared, plus 55 times 3.84 gives us 211.2 t, plus 832 times 0.15 gives us 124.8 t, and 832 times 3.84 gives us plus 3,194.88. Let's combine our like terms. We're going to have 8.25 t squared plus 336t plus 3,194.88. Let's perform a unit analysis on this expression. The units on C are cost at a community college in dollars per student. So the units on C are in dollars per student, times the units on E are millions of students. So when performing the unit analysis, the unit students cancels out, and the units on the result are going to be millions of dollars. There's a typo right here. This should be C times E. Let's fix that real quick. In part C, I want to find C times E of 21. So let's grab our equation C times E from part A, and we're going to plug 21 in for T. So 8.25 times 21 squared plus 336 times 21 plus 3,194 times 0.88. Let's grab a calculator and compute that value. It comes out to 13,889.13. What does this mean? If you remember, your starting year was 1990. So we have 1990 plus the t-value 21 that we plugged in will give us the year 2011. So in 2011, community college students spent spent $13,889.13 million on college. Last, in Part D, we want to use a graphing calculator to determine whether C of E is increasing, decreasing, or neither for values of t between 0 and 50. Just pull up our calculator. So grab your calculator and enter the equation C of t into your y equals menu. And we're going to want to change the window to a window appropriate for this question. We were directed to use t values between 0 and 50, so we're going to change those to our value of x. And for our y minimum and y maximum, we know that the y-intercept of the equation, recall the y-intercept of the equation was 3,194.88, so we're going to want to make sure that our y maximum is larger than that. I'm going to go ahead and start with 5,000. Let's graph this equation. Okay, 5,000 turns out to not be large enough to see what's going on here, so let's make it quite a bit longer. We can see the graph, but we can't see what's going on, so let's make it quite a bit higher. Let's go back to our window and change just the y max. Let's go ahead and look at 20,000. There we go. We can see the shape of this parabola right now. We know that the parabola is going to have a vertex somewhere in the past. If you want to get a better picture of that parabola, we could change the y minimum to say negative 100. Let's take it to, the x minimum to negative 100. Let's take a look just to verify. So here you can see the full graph right there. So you can see that it actually is a parabola shape. And what's happening here for the years 0 to 50 is that it is increasing. The years 50 and 0 correspond to the years 1990 and 2040. So our prediction is the cost of community college is increasing between 1990 and 2040. That's the end of the section.